Okay, we have this piecewise defined function. F of x is x squared minus 1, a square root x plus 1 minus 3, b negative 3x plus 8, based off of whether it's x is less than 0, equal to 0, between 0 and 3, equal to 3, or greater than 3. And so we must first figure out, if possible, give a value of a, give a value for a, which would make f of x continuous at x is equal to 0. It's not possible to explain why. So continuous at x is equal to 0 means that the following things have to happen. The limit must exist, which means that the two one-sided limit as x goes to 0 from the left of f of x, must equal the limit as x goes to 0 from the right of f of x, must equal the limit, must equal f of 0 itself. So we need to calculate out the two one-sided limits here. So the limit as x goes to 0 from the left of f of x, if x is a little bit smaller than 0, we're in the x squared plus 1 part of the definition. Sorry, x squared minus 1 part of the definition. We can evaluate this by substitution. 0 squared minus 1, this is just minus 1. Now, so this right here, that is minus 1. For the limit as x goes to 0 from the right, limit as x goes to 0 from the right, we're using this part of the piecewise definition, the square root of x plus 1, all at minus 3. Again, we can evaluate this by substituting in x is equal to 0, square root of 0 plus 1, minus 3. This is minus 2. And so what do we have here? The limit from the left is negative 1. The limit from the right is negative 2. Those are not equal to each other. The overall limit as x goes to 0 of f of x does not exist. So it is impossible to make this continuous. So for part B now, if possible, give a value for b, which would make f of x continuous at x is equal to 3. It's not possible. Why isn't it possible? Well, what's going to happen now is that we're going to do, let me go to a new slide. We're going to do the same exact calculations that we need. The limit as x goes to 3 from the left, we need that to equal the limit as x goes to 3 from the right of f of x. So the limit as x goes to 3 from the left, that's x is a little bit less than 3. We're using this part of the definition right here. And so that would be square root of x plus 1 minus 3. We can evaluate this by substitution. Square root of 3 plus 1 minus 3. Square root of 4 is 2 minus 3 is negative 1. The limit as x goes to 3 from the right of f of x. Now we're in, that's x is bigger than 3. So we're using negative 3x plus 8 going on here. And so what is going on? We plug in, we can evaluate this by substitution. Negative 3 times 3 plus 8. Negative 9 plus 8 is negative 1. So these two actually agree. So what does this mean? The limit as x goes to 3 of f of x exists and is equal to negative 1. And to finish off our definition of continuity here, the limit as x goes to 3 of f of x needs to equal f of 3. So what does that tell us? That tells us here that b needs to equal negative 1. If we choose b is equal to negative 1, then that guarantees that our function here is continuous at x is equal to 3. Okay, problem number 48, the very last one on the sheet here. Show the equation 3x squared minus x is equal to 2x to the 4th plus 1 has a solution in an interval from 0 to 1. let's move everything to one side. Let's move everything to the left here. And so we have 3x squared minus x minus 2x to the fourth minus 1 is equal to 0. We're trying to solve this equation. And let's define g of x to be 3x squared minus x minus 2x to the fourth minus 1. And so this is going to be an intermediate value theorem problem. Now what we're going to observe here is that g of 0, when we plug in 0 in here, we get 3 times 0 squared is 0 minus 2 times 0 to the fourth minus 1 is negative 1. And I think there is a mistake in this because it's supposed to work out that if you plug in g of 1, you should get something positive here. So you know what? How can I modify this and not? I will update the worksheet and get here that if we make this a plus x, I think that takes care of everything. So that doesn't change the g of 0 calculation. So my apologies for that. I'm going to update the worksheet, the review sheet, with a way to end the final problem with this kind of issue. It's been a long sheet. Okay, g of 1 is equal to, now we plug in 3 times 1 squared plus 1 minus 2 times 1 to the fourth minus 1. This is equal to 3 plus 1 minus 2 minus 1. This is equal to plus 1. And so the thing here is, because g of x is a continuous function, because g of x is a continuous function and g of 0 is negative, g of 1 is positive, then there is x in the interval from 0, 1 such that g of x is equal to 0. Intermediate value property. And I should say g of x takes on all values between negative 1 and positive 1. G of x takes in all values between positive 1 and negative 1. So not only do we prove here that using this new version of g of x here, that not only do we show that g of x must equal 0 for some x between 0 and 1, but g of x must equal 1/2 for some x between 0 and 1. Why is that? Because 1/2 is between negative 1 and 1. So you can see, let me kind of, finish off this last video. If you made it all the way through the end, my hat is off to you. Hopefully these videos were helpful. If I kept it with a mistake in there, g of 1 would have been 3 minus 1 minus 2 minus 1 would also have been minus 1, and that doesn't tell us anything. So that's how I could tell that there was a mistake. Okay. Yeah, hopefully you enjoy these videos. Good luck studying. Good luck with the test.